Okay, so in the first part we looked at how this number here shows statistical significance, and these three numbers, especially these two right here, show us the clinical or practical significance, or can be used to help us decide that they're connected with that. The last thing I want to talk about here is this section of the output, and this is describing the regression line. This is what we might use to make predictions. It's describing this particular line, which is the best fit through these data points. In fact, it's giving the actual equation for that line. So if you remember way back to algebra where a line had a slope and an intercept, that's all you need to be able to plot the line. So this line right here would be, we're trying to predict, I'm going to say predicted deep sleep. That would be our y value, the thing that we're trying to predict here or understand better, equals, here's where we would put our intercept. The intercept is where the line crosses the y-axis. If we were to take, we can't see 0 here on this graph, but if we were to continue to take that line all the way out until we had 0 and saw where this line hits it, it would hit it right before 100. This line would basically intersect with this line right here almost. So that number is 99. I'm just going to round it to 99.6. That's our intercept. And then the next thing we need is the slope. This is the number that's connected to how many minutes, what time I go to bed, basically. And so I'm going to put that as negative 0.232. Let me just round that there, times the minutes after 10 p.m. Now this will not calculate anything right here because I didn't start it with an equal sign. However, I can actually use this equation to predict, let's say I would go to bed at midnight, for example. How much deep sleep would I be predicted to get? Well, right here I can use this formula. So now I am going to do a formula. And I'm going to start off with the intercept, and then I'm going to do plus this. This is my slope. Notice that the negative is built in there. So when I put a negative here, I could have had plus negative 0.232. But since this negative is already on that, I don't need to put a minus sign right here. Otherwise, I'd have two minus signs. And that's getting multiplied by what? What does the slope get multiplied by? Well, it's whatever x value I want to use to predict some amount of deep sleep. So in this case, if I want to predict the amount of deep sleep I would get if I went to bed at midnight, midnight would be 120 minutes after 10 p.m. So I would put 120 in here. And this tells me that on average, based on this model that I've come up with, if I were to go to sleep at midnight, then I could get on average a predicted amount of 72 minutes of deep sleep per night. And there's certainly a confidence interval here. We even see a confidence interval for the slope, that it's somewhere between negative 0.5 and potentially even a positive. Not very likely that it's a positive relationship, but set that aside for now to just understand the basics of what I'm talking here. What I'm saying is this whole model tells me that if I would go to bed at midnight, I would be sitting right here, 120 minutes past 10 o'clock. And if I follow that line up to the trend line, this line that you see on the graph is the whole heart of the regression model's prediction, and I would follow it over here, I would end up a little below the 75 in terms of predicted amount of deep sleep, and indeed that's what I see. I see about 72 minutes of predicted deep sleep. So the next question might be, well, if I wanted to get the minimum amount recommended amount of deep sleep, what time would I have to go to bed? So in other words, I'm going to use this same equation, but now I want this number to be 90, and I want to figure out what this number is. So here I'm going to do a little bit of algebra. I'm going to take 90, that's the amount of deep sleep I want to get there, minus this 99.6 value, and then I want to divide it by this slope. What I've done is essentially just taken this entire equation, plugged in a 90 here, because I want to know what going to bed at what time would give me a predicted deep sleep of 90 minutes, and then I'm solving that equation for this variable. So to solve that equation, I subtract 99.6 from both sides, and then I divide by this. If that algebra seems completely beyond you right now, don't worry about this. This isn't a huge deal. The point is, or feel free to contact me about that, I guess I should say. Don't worry about it in this particular instant, but do contact me if that algebra seemed like a whole mystery there. So anyway, if I press enter here, I get 41 minutes. Let's make these a little prettier here. Let's just get the actual nearest number. So 41, what does that mean? That means if I would put a 41 in here, I would get a predicted deep sleep of 90. In other words, if I would go to bed at 10:41, this model is predicting that on average I might get that minimum 90 minutes of deep sleep. And what if I wanted to go crazy and I wanted 100? Well, let's do it the other way around. Let's say that I go to bed at 10 o'clock itself. That would be crazy. I can't imagine ever going to bed as early as 10, getting my stuff done, going to bed at 10. But let's say in a dream reality, I was able to sleep at 10 p.m. How much predicted deep sleep would I get there? Well, that would mean this value is a 0. The 0 would get multiplied by this number, which would give me still a 0, which would mean I'd get a predicted deep sleep of 99.6 minutes. Wow, I can't even imagine that. Or let's get even crazier. Let's say I went to bed at 9 o'clock. So this would be minutes after 10. It would be a negative 60. So let me actually, let's just take advantage of the formula I've already typed here. Instead of 120, let's say that this value was negative 60. I'd get almost 2 hours of deep sleep. Now the danger here is I'm doing something which is called extrapolation. I'm starting to go beyond the data points that I have. If I said even that 1040 right there is pushing it right at the edge of the data I actually have. When I say I go to bed at 10, that's way over here. 9 o'clock is off the screen because I've never done that, and so I can't reliably trust this model for that kind of data. Same thing over here. If I would say go to bed, let's say I pull an all-nighter or something, go to bed at 3 p.m. Oh no, that's a lot later. 7 a.m. the next morning. How much sleep would I get predicted? I would predict negative deep sleep amount, which is impossible. That's clearly not correct. And this shows you the danger of extrapolation. Extrapolation would mean making predictions for the y value when your x value that you're predicting for is beyond the data you've collected. So to the right of here, or to the left of here, in either direction, that's considered extrapolation. You can do it, people do it, but the further you get away from the data points, the less reliable you can depend on your model to make accurate predictions, and in some case they're just complete nonsense. So that's the regression line. That's how to use it, interpret it. Final question I want to address here is this week we talk a lot about correlation versus causation. So the correlation is clearly coming here. Where does causation fit into this regression, and why is it in a week on regression? So causation can be determined potentially, or evidence for it can be through any statistical test. You can do it, and it's often done through a t-test, through an unpaired t-test. The reason why we're putting it in regression is because regression it's the most methodical tool to go from that initial correlation to start digging into all the things that explain that correlation and try to figure out what's actually going on with the causation. It's the most, there's many more sophisticated tools to do that, but regression would be one of the most basic tools to start getting at that. In order to really do that, what we need to do is put in extra variables in our model. I mean, I know that I go to bed later, and that means on average I get less sleep, and that's probably a true relationship. What I don't know is that going to bed later causes me to get less deep sleep. For example, it might be that the times that I go to bed later, the nights that I go to bed later, tend to be the nights when I'm more stressed, and that's a very strong possibility. I'm pretty sure that that's true. And maybe on the nights that I'm stressed, I tend to get less deep sleep. So maybe it has nothing, even if I would manage to go to bed early, but with that amount of stress, I might get less deep sleep. That's what we call a lurking variable. It's what stands in the way between a correlation and a causation, that lurking variable. Another one might be the nights that I go to bed very late, I have maybe I'm experiencing some physical symptoms, maybe some heart palpitations, indigestion, whatever that may be. And so maybe those are really what's causing my lack of deep sleep on these particular nights, rather than just the time I'm going to bed in that sense. So that relationship is not very clear yet, and that's why we need to start looking at these lurking variables. To look at them, we pull them into the analysis. We actually bring them in so we can see how much they may or may not be influencing the relationship between these two variables. And that's what we'll look at next week. In order to do that, we need to throw more variables into the regression, and that'll allow us to check more closely for causation. If we could identify all the major lurking variables, pull them into the analysis, and control for them, then we could start moving from a correlation to a causation. The danger is we never know if there's lurking variables we're not thinking about, and that's where a true experiment, where you randomly assign the groups to two or more treatment groups, that random assignment helps balance those lurking variables, so it kind of takes them out of the equation. In many cases, we can't do an experiment. As it turns out here, we actually could do an experiment. What I would do is every evening flip a coin. If it was heads, I go to bed at 10 p.m. If it's tails, I at least start trying to sleep at midnight. That's something, the started trying to sleep, I have control over. So I could randomly assign, and by doing that, I could actually get a very good answer on what, at least going to bed between 10 p.m. and midnight, the difference between those two is in terms of average amount of deep sleep. So the problem is there's so many different variables out there, 20, 30, 40 variables, and even if I could design an experiment for each one individually, that would take a lot of data points to test that out. The advantage of a regression is that I can look at all these variables at once, and that's what I'm going to do next week in this multiple regression. So that will allow me to identify the most possible predictor variables, what might be causing this lack of deep sleep, and then I could always do look at specific experiments. But both of those, whether I use regression or t-test or something else, really what I'm trying to do here is find the cause of my lack of deep sleep so that I can change it.